tomorrow will be better. A 10 kg ball is thrown into the air at 3 meters per second. What will be its potential energy when it gets to the top? The first thing here, dear friends, is to understand what's happening with the ball the very moment it gets thrown into the air. Follow me, dear friends. Solution. Now, the moment this ball is thrown into the air, before it gets to its top, what happens is this. This speed of 3 meters per second starts reducing due to the effect of gravitational force on it. Now, it reduces until it eventually gets to a velocity of 0. Now, it gets to this velocity when it reaches the top. Now, they are asking us to find the potential energy and not the kinetic energy. Now, one important thing to take note of here is we will have to apply the law of conservation of energy, according to which the initial energy, which is the potential energy, which is the kinetic energy which this ball had from the start, will completely be changed into potential energy when it gets to the top. And to assume this, we have to make another assumption, which is that of neglecting air resistance. We will neglect air resistance. At a speed of 3 meters per second, air resistance is not really considerable. Now, what energy does it have at the start, the moment it is projected? It has only kinetic energy. Now, kinetic energy, which is given by half of mv squared, it will be given by half times the mass, which is equal to 10, and then times 3 all squared. Now, if you punch this correctly, this should give us 45 joules. What happens is this. As this object keeps rising up to its maximum height here, the moment it is rising, this kinetic energy is gradually reducing and being converted to potential energy. And when it reaches here, there is no more kinetic energy because, dear friends, when it reaches its maximum height, it gets to an instantaneous stop. It stops for a fraction of a second before it starts falling. So the moment it stops, all the kinetic energy that it had from the time it was projected, which is this, is now completely changed to potential energy. So potential energy at this top is equal to the net kinetic energy that it had right from the start, provided we are negating air resistance. So the answer to our question here is simple. Potential energy at the top will simply be kinetic energy at its start, which is equal to 45 joule. Tomorrow will be better.